if you want to show the deviation in your data. Okay, so when I am saying the deviation or the variation from a certain point, okay, most of the time whenever we are draw the deviation perspective, so that means the target value we are considering is 0, but you can also set certain point as well. Okay, so that means some of the data point are going to be above the 0 point, that is a reference point. Some of the data points are below the 0 point. So for that we can plot either the type of the bar chart which is known as diverging bar chart, either we can use diverging dot plot, or either we can use lollipop chart. Okay, that is a diverging lollipop chart. So basically the basic objective of all three plots are the same. So that means that objective is to, from the reference point, we want to see the data points are above that reference point and below that reference point. Okay, so for that, basically, I'm again using a built-in data, which is empty cars data. So if I run this data set, and then I'm calling that empty cars, so I can check this data set, which is basically the different type of cars we have, and then we have the different types of variable, which is mileage per gallon and the type of cylinder, then horsepower and so on. So these are the different type of variables we have. So right now I am interested with respect to the mileage per gallon. So I want to know on average which cars are covering more mileage per gallon, okay, compared to the others. Okay, so for that I'm using a divergent type of bar chart. So for that, first of all, what I am going to do is I am going to calculate the reference point. And what would be the reference point? That would be 0. Okay. Okay, so how we can calculate that one? That is with the help of that reference point, which is basically the 0. I am going to calculate the z-score of the variable, which is mpg, that is mileage per gallon. So the formula of z-score is going to be mpg, that is the variable, okay, minus the mean of this variable divided by the standard deviation of this particular variable. Okay, so the interpretation of the z-score is the number of standard deviation your particular data point is lying away from your mean value. Okay, so with the help of this z-score we can calculate the center point, or you can say the reference point, which is going to be 0. Okay, so how we can do that? So first of all, in a R code, what I am doing is I am first of all creating a column in order to draw the divergent bar chart. I'm creating a new column with the name of the cars, which is basically that is the name of the cars. So I am creating a column now. If I am again calling that data set, as you can see that there is a column with the name of car names. That is exactly the name of the cars. Okay. Now I am calculating the z-score. So how we can do that? So I'm using a function round. So with the help of round function, I can round it up to 2 decimal places. Then I am calling the variable, which is empty cars, that is the name of the variable in which we have the data set. And from empty cars, I am accessing a column which is mpg. Okay, that is the name of the variable, minus we are calculating the mean value, and then we are calculating the standard deviation with the help of sd function. So if I run it, and then if I want to visualize this graph, so with the help of this variable, which is empty card $mpg, so it is going to be add another column with the name of mpg underscore z, and that variable we can see in our data set, which is mpgz. So this is the z score of Mazda RX. Okay, similarly we have Mazda RX WAG and so on. So these are the z scores. Okay, so as you can see that some of the z scores are positive, some of them are negative. So that mean our mean point, or you can say our reference point is going to be 0. Now what I am doing is, now I am classifying them, which car is going to be above the referencing point, which are going to be lower the referencing point. So for that I am using a function called if else. I am saying that if this particular variable is going to be less than 0, so write down below the average, otherwise it should be above the average. So if I run it, and again run it, now you can see that they have mentioned another type of the variable, which is mg underscore type, that is with the help of this command. Okay, and it is mentioning if the value of mpg underscore z is greater than 0, it is mentioning above, it is negative, then it is mentioning below. Okay, now we are ordering this data set in a ascending order. Okay, so we are sorting this data with the help of this order function. Okay, so now we are sorting it, and then once we have sorted it out, like you can see all the belows are first, and then all the aboves are next. Now we have to make sure that our car names variable, because we want to see which type of cars are below average, which type of cars are above average. It should be the factor type. So there are two ways to convert a particular variable into the factor. Okay, although the car name is already in a factor type, but it is good practice to make sure it should be in a factor type. So either we can use the function as dot factor, or either we can use the function factor, then the name of the variable, which is the car name. Okay, and then we are mentioning the levels, so which mean this particular variable having how many values. So we are saying that it is equal to the car name, so that means every name is a unique name. Okay, that there is no repeating number. So that's why the level is going to be exactly equal to the name of the column. Okay, now if I run this one, now we can again checking the data set. Now in order to draw the divergent bar chart, what I am doing is I am saying ggplot, the name of the variable in which we have data set. On x-axis we want to draw the name of the cars. On y-axis we mention this z-score value. Okay, and then we are saying label this with the help of z-score. Okay, we are drawing the identity. Okay, that is the side by side bar chart, and then we are mentioning we are filling those bars with the help of mg types, that is below and above. Okay, so we will see the two types of bars. Okay, one is with the help of below and other is going to be above. So this fill is going to be filled with the help of these mg type. Okay, as well as we are mentioning the width of those bars, and then we are mentioning labeling those bars, that mean above average as well as below. Okay, and as well as we are also mentioning the color type. So we are saying that the above bars color should be equal to this one. So you can also mention red and green even by using the English words. Okay, so these are the just codes to represent certain colors. So this is representing with the help of below. So if I run it, and then as well as I'm saying coordinate flip. So let me run this without coordinate. Okay, so if I run this one, so as you can see, on axis we have a car names, on y axis we have mg underscore z. So if I use this one, okay, this coordinate flip, so so now you can see that on y-axis we have the name of the car because we have flipped the graph. On x-axis we have the z-scores. So this green color is indicating the name of the cars which having on average more mileage per gallon compared to these cars. Okay. So in addition to the bar chart, we can also draw the you can say dot plot. So all the things are going to be same, only the difference is instead of using bar we can use point. Okay, The rest of the things is going to be same. So if I run it, so you can see instead of bars, there is a dot plot. Similarly, if you want to use the lollipop plot, then in addition to the point, we have to mention the segments. Okay, and in the segment, we are mentioning that the y-axis should be start from 0 and ended up to the mpg underscore z. So that means whatever the value of the z is, it should be end from that particular point. So if I run this command, so now you can see that this is the diverging lollipop plot. So starting from 0 to that z score. Okay. So I hope it's clear. So if you want to show some deviation, then you can use out of these three plots either bar chart or a diverging dot plot or a lollipop plot.